Hello everyone. Today we are going to talk about a series solution UXT of the following equation. This is a heat equation. So you differentiate U respect to T equals A squared UXX plus FXT, and the initial boundary condition U0T equals G, ULT equals H, and the initial condition, this is initial condition. So we call this is initial condition. So these two are called boundary condition. And then here, the function f, so the function f, g, h, l are given function. In particular, L and L prime, these are piecewise continuous. So L is continuous and L prime is piecewise continuous. And for now, we just assume the F, G, H, these are continuous at least. So I didn't write down here, but we assume that it's continuous. Okay, so today's goal is to find the solution of this equation. So once you have this solution of this, then whenever F, G, H, L are given, A is given, you can find the solution, right? Okay. So what is step one? So we're trying to get a solution of this. And step one, so in order to get a form of a solution, so we need to look at very simple case. Okay, a very simple case. We consider very simplistic case. So step one is that the function f is 0, g equals 0, h equals 0 case. Okay, so we assume that f, g, h are given. Then in this case you have u t equals a squared u xx x between 0 l, and t is positive, so u 0 l equals 0 u, oops, not L, 0 T, U L T equals 0, and the U x0 equals LX. Okay, you see that this is exactly the problem we already solved at the beginning. So let me just quick review. In this case, what is very important thing is this. So in this case, when we, I think our previous lecture, my previous lecture, I explained to solve this equation. Then step one was we look at xt equals xx tt. Okay, so separation variable solution. You plug in here, then let's see. So on the right hand side, I will put it xx t prime t equals a squared x double prime x tt, and then you divide it by xt. Oh, I'm going to divide a squared too. You cancel them out, so this cancel out, so this constant, so this should be lambda. Then we obtain the x double prime plus lambda xx equals 0, and then t prime plus lambda a squared tt. Okay, so this equation. So then you have a one that's called 1 prime, 2 prime, 3 prime, 4 prime. Okay, So then we need to find the solution. So let's see, x double prime x plus lambda xx equals 0. And then from equation 2, you have x0 should be 0, xl equals 0. So I have this equation, and then we have a heat equation. So T equals minus lambda a squared tt. So this one. Okay, so that's what we had. And then we already know how to solve this equation. This is easy to solve. So in this case, we previous lecture. So if lambda equals k square pi square divided by l square, then xx equals sine k pi x divided by l. And here k is natural number. And then if lambda is not equal to this value, then xx should be 0. And then at the same time, in this case, tt should be, I remove the constant, so then exponential minus k square pi square divided by l square a square t. So then you remember uk xt equals exponential minus k square pi square divided by l square a square t sine k pi x divided by l. So this would be a solution satisfying 1 prime, 2 prime, 3 prime. Okay. So in this case, we don't worry about. So now this one is called. Yeah, I remove this. Okay. Let me label. This is equation 1. This is equation 2, 3, 4. This is a 5, 6, 7, 8. Okay. And then this guy, uxt, so for each k in natural number, uk satisfies 5, 6, 7. Okay. So then you remember the previous lecture. Then we assume that let u xt equals summation k from 1 to infinity ak. So I think I used bk. bk u k xt. Then we are assuming, so once in this case you have to find bk and then take a limit, and then you need to prove some uniform convergence or some other things. So then we assume that we know that this uk satisfies 5, 6, 7. Then we assume that u satisfies 5, 6, 7. So sort of assuming, so u satisfies 5, 6, 7. Well, you can actually prove this one after we find bk. Okay, so that's a little thing to prove. But in our textbook, so the textbook says superposition, theorem of superposition, but I didn't mention yet. So then in order for you to satisfy the 8 condition. So from 8, condition 8, then u x0 should be Lx, okay? And then this will be summation k from 1 to infinity uk or a bk uk x0. That would be exactly k from 1 to infinity bk this sign k pi x divided by L. So this should satisfy, okay? This should hold. Then if we take, if bk equals 2 over L, 0 to L, Lx sine k pi x divided by L dx, okay? Then those stars equation, let's go 9. So 9 equation, actually a Fourier sine series. So the expression to 9 and right hand side 9 equation, actually the Fourier, this is the Fourier sine series for Lx, okay, L, and by a Fourier theorem. So we assume that L is continuous, L prime is piecewise continuous. So that implies that by Fourier theorem, so Lx converges summation k from 1 to infinity bk sine k pi x divided by L is actually converged to Lx. So this converge means the same. So we're done. So from here, we know that bk. We choose bk, and then you plug this one over here. Then we are solution. So finally, we have solution. So we obtain uxt, a solution of 5, 6, 7, 8. Okay, so that's what we had before. So then this is step 1. But when you take exam, you don't need to write down all these things. The most important part is this. This guy. These are most important part. This. So lambda equals k squared pi squared L squared. Then we have x-axis sine k pi x divided by L. So these are very important part. So you don't need to do with two, 3 things. So whenever you have this problem, the important problem is this: the solution of x, eigen value and eigenfunction x. That's the most important part. And in general case, step 2. So step 2 is general case. Step 2. So we don't assume that, okay? That's step 2. So we try to find the solution of this, okay? So then by step 1, what we want to do is this, okay? So suppose that anyway we're looking for solution, right? So uxt is a solution of, okay, equation 1, 2, 3, 4. Okay, we want to find the solution. And then most important part is this: for given t, so you fix the t first. Okay, whenever phi is fixed, then here uxt t is fixed. This is a function of x. Okay, then you consider we consider u xt as a function of x. Okay, you fix the t, a function of x. Okay, x between 0 L. Okay, then what I told you before, then lambda equals k squared pi squared divided by L squared, then you have this, right? So then we have Fourier sine series. Okay, here this is the most important. And then we expand, we use the Fourier sine series. UXT, okay, that's most important. Then what is the Fourier sine series? So then you can write UXT equals Fourier sine series means k from 1 to infinity bk, and then sine k pi x divided by L. This is the Fourier sine series. And then I put some little spacer here. What I'm doing here, this coefficient of k bk is actually depends on t. So this depends on t because I fixed t, and then I use Fourier sine series for uxt. If you change t by another value, then bk will be different. Okay, so here where you have a bk t equals 2 divided by L, 0 to L, u x t sine k pi x divided by L dx. Okay, so this is the most important part. So if you don't start with this kind of form, your answer will be totally different. So you are not able to solve the equation. Okay, so this is the most important part this case. Okay, these are the very important part. This is very, very important. Okay, then so once the first step is to this one. Okay, this is the most important part. So I put this one to be small number 1. Okay, then small number 2 here. So then I need to find the bk. So find the bk. That is step 2. Find the bkt. Okay. So how do I find the bkt? So now we have to use equations. So let me what was our equation? So I don't scroll, so I just write down here a squared u xx f xt u 0t equals gt u lt equals ht, and then u x0 equals lx. Okay, so this is our equation, right? This is our number 1 I labeled at the beginning, number 2, this is number 3, number 4. So we need to find the bk. So then we have to use equation 1, 2, 3, 4. Okay, so let's see. Then I compute the bk prime t. So bk is this one, and that is function of t. Then your integral here, integral actually respect to t, x. So integration is independent of t. Then you will immediately get that your derivative should be 0 L partial u partial t or xt sine k pi x divided by L dx. So that's what I have, right? Then we use equation. So from number 1 equation, so here now you use equation number 1 to get 2 divided by L, 0 L, And that equation a squared u xx. So I put variable 2, then plus f xt, and then sine k pi x divided by L dx. Okay, I just replace partial derivative of u respect to t, okay, by a squared uxx plus fxt. And then let me split two pieces. And I split two pieces, I also take a outside. So the first term becomes 2. Oops, I don't like this color. I make match. 2 divide the L a square integral 0 L u xx xt sine k pi x divided by L dx. And then 2 divided by L 0 to L f xt sine k pi x divided by L dx. That's what I have. And then and then you need to use integration by part. So here let me give you some formula we're using all the time. So I put here formula. I'm not sure it's enough. Okay, let me write first. Okay, and let me rewrite here. Sine k pi x divided by L dx. Okay, so the formula is here. Integral a to b f double prime g equals f prime g minus f g prime, and then plug ab plus integral ab f g double prime. Okay, so this formula can be obtained by integration by part twice. So we need to that formula all the time. So you need to get used to it. So let me apply this formula. Then you get 2 over L a squared. So that would be, I have big parentheses. So this is u x t sine k pi x divided by L minus u xt. So this would be g. You take a derivative, then k pi. So let me put coefficient outside. So then k pi divided by L, derivative cosine k pi x divided by L, and then I have a 0 L. Okay, let me put big parenthesis, and then plus integral 0 L u xt. Okay, and then you need the derivative twice of this one, and you'll bring minus sign. So then you will have minus k squared pi squared divided by L squared, and integral 0 to L u xt sine k pi x divided by L, and the big parenthesis, and then I just put 2 divided by L. I need more space here, so I'm not next line. Okay, then I have a plus 2 divided by L integral 0 L f xt sine k pi x divided by L dx. Okay. Now, so you plug L 0. So now I'm using equation 2 and 3. So here, now you equation 2, 3. So where is equation 2? You put 0. So anyway, you put L this term becomes 0, 0, 0 done. This term will be gone. So then you have minus k pi divided by L square. Oh, also I have 2. Okay. So then minus k pi over L a square, and then 2 divided by L. I just split like this one. For this one I just, okay. Just 2 a square k pi divided by L square, first term. So you take this guy with this. So 2a square k pi over L square. Then you plug L, this term is 1 minus cosine k pi. So cosine k pi. So you have here, and then I have minus k square pi square divided by L square, and then I have a square, and then 2 divided by L integral 0 to L, this terms u xt sine k pi x divided by L, and then I have the last of dx plus the last term, so 2 divided by L integral 0 to L f xt sine k pi x divided by L dx. Okay, so I have here. So by the way, so let's look at this term. So what was bk? Bk was 2 divided by L integral 0 to L uxt sine k pi x. Here, look at here. This is just the bk, right? This is the bk. So what I have here, finally, I have, oops, can I remove this guy? So that would be, so this is bk. So this minus k square pi square divided by L square, a square, and then bkt. Okay, the other one, this is just the constant. Okay, this is just a constant. Also, this one is what? This you integral with respect to t. This is a function of t. This is a function of t. Okay, so then I will put this just the h of t. Okay, so here where this ht equals 2 over L integral 0 L f x t sine k pi x divided by L dx plus okay, that plus 2a square k pi divided by L square 1 minus cosine k pi equal minus 1 to the kth. Okay, this is my ht. So then we obtain the equation, right? So finally we have b prime t equals this. Okay. So finally what we had, so we obtain b k prime t equal to minus k square pi square divided by L square a square b k t, and then plus ht. Anyway, this ht is actually determined by, this is the given. This is given, a is given, so everything is given. This is actually known value, known function, okay? Because f is already given in the problem, so this is known. Unknown is bkt. So by the way, so you have this first order differential equation. So we need one more condition to solve exact solution of this one, right? So what kind of condition we need? So this is not enough to solve. We need one more condition. What condition? I need a BK0 condition. So once you have this, then we can solve this equation. So then let me try to find BK0. So what is BK0? BK0 was what? Where is it? BK0. Yeah, this is BK. You plug in 0, then that you could check 2 divided by L, 0 to L, U, 0, this X, T0. So me plus X comma 0 sine K pi X divided by L dx. Okay, and then I use equation 4. This is Lx, 2 divided by L, integral 0 to L, Lx sine K pi X divided by L dx. So this is given. So this is also given. So let's call this one is B0. Okay, let's call this is B0. Then you put B0. Okay, so here where B0 this. Okay, this is step 2. Step 2 is you need to find the BKT. Then we need to solve this. Let me call this equation 10. So we can solve, we can obtain, we can get explicit, we can get explicit, or we can get solution of it, or we can solve. Okay. We can solve equation 10 to get BKT. Okay, that's step 2. And then step 3, just combine together. Okay, so finally we have U xt equals summation k from 1 to infinity BKT sine K pi X divided by L, where BKT where is obtained from equation 10. Okay, not find. So finally remove this. Remove this. Finally, this is a solution. This is a solution of 1, 2, 3, 4. Okay, so this is the final step. So step 2 is the most important part, is a small little one part. Okay, so we need to find a form of a solution. So a form of a solution here. This is a solution here. This is the most important part. Actually, if we want to prove rigorously, you need to prove rigorously, then we need to do more. Okay, then I don't discuss too much. Okay, thank you very much.